Good afternoon, ladies and gentlemen. It is the second day of IMC, and today we are here to talk about a very burning topic, if you will, a very pertinent topic in today's scenario, which is about AI on the edge or the next wave of AI. Uh, for decades, artificial intelligence lived in data centers where there was sufficient compute power to perform processing, demanding cognitive tasks. In smart and connected communication world, AI has made its way into the software, where predictive algorithms change the nature of how these systems support the business. Now, as we see, AI has moved to the outer edges of the network. This AI on the edge brings the processing and computing capabilities to the embedded Internet of Things, our IoT endpoints, the IoT gateways, and other devices at the point of use. It is a real-time event. Um, it is a real-time event technology powering everything from smartphones to smart and automated sensors. Some of the points that we need to, which keeps us quite interested on this topic is that a Gartner survey says that 85% of industrial enterprises will be utilizing edge computing by 2023, with the multi-axis edge computing market, which is set to reach $7.23 billion by 2024. The global edge AI software market size is projected to reach nearly $1.85 million by 2025. In addition, we have also seen that some projections say that a CAGR of 26% is actually possible from 2020 to 2025. We have also seen in our various KPMG surveys that enterprises have shown an inclination to spend on an average 30% of their IT budgets on edge cloud computing over the next 3 years. Now, as we talk about edge today, I would like to introduce my esteemed panelists. So who we have today is a host of experts who are experts in the field of AI on the edge. I would like to first introduce Manish Sinha. He is a CMO with Sterlite Technologies. I mean, he has donned many hats, as we all know. He has been with McKinsey, then with Infosys, and today he, if you talk to Manish, you will always find very interesting and intelligent communications on various use cases that businesses are supposed to do. My next speaker is Sachin Desai from Ericsson. He's a global VP of Ericsson and heads the AI Accelerator team. He is based out of Silicon Valley, and his primary area of focus has been AI on the RAN edge. Our next speaker is Rohit Kaw. He is from Cisco, and Rohit has been he heads the sales of networks and clouds with Cisco. He has been there in Cisco for quite some time, and his primary area of focus has been the infrastructure areas of edge computing. My next speaker is Kuntal Chowdhury from Mavenir. Kuntal is an SVP and General Manager with Mavenir, and especially focuses on the AI and Analytics BU. We also have Vijay Thomas, who heads Tangentia and is a special invitee to us from the Canadian High Commission. And my last speaker is Ameeta Roy. She is the Chief Technology Officer of Red Hat in India and South Asia. So, a warm welcome to all of you as we start discussing and picking our brains on how AI has been the next wave of AI over the edge. So why don't we start off with Manish? And Manish, you have been in your conversations with various clients and as well as for Sterlite Technologies. How do you see would be the potential use cases that AI on the edge would need to focus on? I mean, we have already heard about predictive maintenance. We have heard about smart buildings. We have heard about speech recognition. But what are some of the use cases you think are pertinent today?
Thanks a lot, Dipayan. I think edge computing has been a matter of discussion for quite some time, and so has AI been. And I think we are now coming to the point where AI actually happening on the edge is almost going to be a dominant conversation going on. There are many use cases. There is just no way I can talk about all the ones. But broadly, there are two major types of use cases. One is the consumer use case, and the other is the industrial use case. In the consumer use case, like you said, speech recognition or on-the-fly image recognition-based tasks are going to take more and more dominance because, as you all know, for example, a car can generate in an hour the amount of data that will take about 10 hours to upload, right? So we cannot actually give all the data that is being generated from users to the deep ends of the cloud and get responses. We have to get stuff done at the edge. And clearly, training takes a lot of time. So the edge use case from a consumer perspective is going to be primarily pre-trained models sitting at the edge. Yes, there will be some amount of training, and but we don't really expect full-scale ResNet sitting at the edge. So that would be the most important thing. And the way I like to think of it is a parallel, and especially for the consumer use case or user use case, is like think of the edge AI as a spinal cord, just like we have in the human body, for quick everyday reflex actions. Right? I'm trying to talk to someone, voice typing, live translation, using vision AI for context detection. That's the kind of stuff that we will see come up most importantly for everyday use cases. Like, I want to write a document, and in the document, all of us are slowly using voice typing. So, the office programs like Google Office or Microsoft Office will try to enable edge AI for voice typing. I think that's one of the most early use cases. Also for reasonably local predictive engines, right? Like, for example, I want to buy something from a local market here, and don't want to actually go all the way to some massive server to figure out all the data that is available in any case in my local area. So there is some amount of local predictive modeling, predictive recommendation engines that will sit at the edge. That's what I see happen in a more larger sense for consumer, but the bigger use case will be in the industrial use case. I was surprised to read this, but Forrester says, and it's not surprising that the number is so large, that about 60 to 73% of data from the enterprises that are captured today are unable to be analyzed because of the the models that are available or can be available are generally far off, right? You need quick tuning of factories. You get a blip here, you need to get quick smart decisions, and those are the kind of things that we would see happen, that thousands and thousands of sensors are providing information, and right at the edge decisions will be taken, like routing material to a different line based on blockings and stuff like that. Now, you can actually pre-program some of these things, but there is a limitation to how much you can pre-program. So sensor data going to the spinal cord rather than the brain is something that the human body had invented millions of years ago. And since we are in the world of AI, we always learn from that. So it's very, very clear that some of these things will be done in the edge. And some of these things will create, so that you said predictive maintenance. I think basically I'm saying predictive maintenance is going to be one very big use case. But we will actually have to contend with problems like security and privacy in such a situation. Now, in some sense, security and privacy is materially easier if you're keeping information on the edge, because you're not sending it to the server, and therefore it's not hopping on so many nodes, not so many leakage points. But you now will have to contend with creating secure protocols and control mechanisms at each edge location rather than having it central. So there are still some challenges to be filled, but it's very unlikely that in the next couple of years we don't see so much more happening at the edge. And then I certainly think that it will start with consumer use cases, but it will really balloon in the industrial use cases. So that's what I think.
Right. Yep. Thank you so much, Manish. And as I would like to bring in Sachin out here. Well, I mean, I do understand that, and we have been talking that your definition of edge is primarily on the deep edge rather than the classic edge of CPE and end devices, right? Now, when we talk about applying AI on the edge of your RAN portfolio and areas around that, how do you see Ericsson doing it, and what is your perspective there?
Right. Thanks, Dipayan. And I'll shift focus because Manish mentioned more use cases in the consumer and industrial space, and Ericsson is actually a connectivity infrastructure provider. So a quick word on what our overall ambition with AI is, right? So our AI ambition is to move towards a data-driven, cognitive, intent-based approach to both building and operating networks, because a lot of cases where we are actually operating huge networks across the globe, right? And we have built a fairly large team over the last couple of years, a 300+ member team of data scientists, data engineers, AI architects, to do this transformation of our portfolio, our services portfolio, products portfolio, and our own internal ways of doing things as well, right? So, and quite a bit of this team actually exists in India. A good 35-40% of my team, global team, is in India with some very high quality talent. So for me to be able to explain what we do at the edge, I need to give a quick backdrop of how we are applying AI overall, right? I mean, we have built about 250 use cases, several of them piloting with some of the largest operators in the world, a few in India, and several in Europe and North America as well. What we are doing is building AI capabilities into various planes that we have, right? The management plane, the operations plane, as well as the networks plane. And what goes on the edge is largely a function of what kind of latency various control loops can afford. There are certain things that need to be done real time. Manish talked about inference at the edge, but learning happening centrally. We have most of the paradigms are of that kind, but we have cases where we have to train real time at the edge as well, right? So what I thought I'll do is I'll give you two classes of use cases that we are building on the RAN edge. Underneath that, of course, these map into tens and hundreds of use cases, but primarily two large families of use cases. The first, I mean, all of this is towards being able to optimize the RAN edge in terms of how they operate, right? So the first one is the network optimization. Over the years, network optimization has been done through various algorithms that are implemented within the node. But now with the advent of AI, what we have been able to do is a specific RAN node can actually learn from its neighbors and from other nodes in the network and make decisions that are optimal for the network, not just for that particular node. Functions like load balancing, power management, handovers, and these are all very complex problems in the networking, in the RAN world. And we are starting to do this by optimizing at the network level rather than at the node level. That is one class. The second one perhaps is more interesting and an engineer's delight. Over the several years, we have, as a company, we have mastered the algorithms that go into these complex products. What we have done is, we've highly hand-tuned algorithms that are implemented in software and ASICs. They function very, very well, but they're not as adaptive as environmental changes happen, as deployment paradigms change. They're not as adaptive. So we are taking a data-driven approach to those things to tune those algorithms. I'm saying it in very, very simple terms, but this is an extremely complex operation. So we have tons of algorithms that do various specific sub-functions within the operation of a RAN. And we are taking an approach where we are making them adaptive by using data. So to summarize, we are doing a lot of use cases which involve the RAN edge. As a part of preparing for this discussion, I looked at the percentage of the use cases that involve the edge. A good 20% of all the 250 use cases involve the edge, which is huge. And that number is only increasing because the more you can do in a low latency, short control loop manner, the more functions you can implement. Right, but it's down to these two things: the way we operate our RAN networks, the core network, and being able to do things quickly at the edge without shipping everything up into the main cloud is the essence of what we are doing at the edge.
Right, perfect. So I would like to bring in Rohit out here from the infrastructure side of things, and we all have been talking about the necessity of security. The necessity of providing a security assurance and data privacy, and especially bringing a cost-effective edge network. How would you see that changing the infrastructure deployment?
Hey, thanks, Dipayan. It's a great question. If you see, right, the whole paradigm about edge is around the three key use cases that it tries to solve, and that's the approach that that we at Cisco are taking. So if you see from an edge perspective, there are three key use cases that edge is trying to solve. First is around latency, right? Manoj also alluded to it, and that brings out two key benefits. One is, of course, your consumer or your customer better quality of experience, and the second is it also leads to unlocking of a lot of incremental revenue opportunities that you can monetize. The second is around data reduction. We've seen over the years, right, the data explosion has just taken off, and gone are the days where we could pump in everything centrally to a central location, or in recent time to a central big cloud, and get gratification from it. So the amount of data that we're pumping is making that economy, very difficult to scale in terms of the cost, and also in terms of the time that it takes to build all of those humongous backhaul capabilities to take all of this data into a central location. The third is really around bringing analytics, offload, and interconnect. So this is where you pump in the data to a local processing unit, and that could have an interconnect with multiple clouds or to multiple content CDN networks. So you really optimize the flow of traffic. And we at Cisco, what we've done is we've really taken that as the yardstick for developing our strategy and our solutions. So these are, if we had to take a look at these three outcomes that we have to achieve, which is around data reduction, around low latency, and providing offload and interconnect, then you sort of need three key things to fall into place to be able to do this consistently and cohesively. The first is really where it all starts is the infrastructure piece, right? So when you're talking edge, you're no longer talking about a protected control environment like a traditional data center has been built, or an MSC has been built, or how even enterprises have built their remote offices or small branches, right, which is still a control environment. Now these edges are going to be really out in the field. We've seen that happen with 4G, and with 5G, it's only going to proliferate further down into the far edge. So from an infrastructure perspective, you need to have that robustness. You need to have that ruggedization to be able to stand to those kind of operating environments. And India does bring out its own set of challenges in terms of pollution, in terms of the dust concentration. So they have to be extra customized for India. And then from a logical perspective, you need to have all the right layers, right, from a virtualization perspective, cloud native perspective, like the networking constructs that will make seamless, mobility of consumer workload, or as Manoj was alluding to, business and industrial workloads, around these thousands of edge locations that you will have. And of course, to
Right.
power it, all up, right, you will cannot do, you cannot be, you cannot be digital without security, right? So there has
That's
to
right.
be a layered security framework, built in, you know in conclusively, within this framework, right, rather than as an afterthought. So that framework comes in nicely with that. And then finally, riding on top of it are the actual applications, right, the ones that will help better the quality of experience for consumers. And those will be maybe service provider workloads, or it could be enterprise, or a bank, or a gaming content provider. There are many examples, of those that will help monetize and bring additional, quality of. So we definitely play in that. And then from an AI perspective, how we are applying it is that when you talk about edge, right, this is no longer going to be a couple of dozen locations, right? You're talking thousands and thousands of locations. And in a large country like India, or or United States, right, these are going to be really tens of thousands of locations. So how do you orchestrate and automate across these all of these locations? And how do you apply machine learning, right, artificial intelligence, to really arrive at two things? One is, how do you keep all of these edge locations sane in terms of doing proactive maintenance? In fact, we are working on assurance, which wherein once a network is, or we detect that there is going to be a problem, we take proactive steps to actually rectify it even before the problem has occurred. So something, we are working towards a self-driving cars kind of a network construct. And then finally, also for the applications that will ride on these edge infrastructure. Uh, so for those deep learning, we do have solutions that provide very granular and deep visibility into every aspect of what that particular application is doing, whether it is for the consumer again, or whether it is for the business. To give you an example, right, we have today, there exists capability that we can actually derive, if, let's say, for a fintech or for an e-commerce customer, if a payment is getting, let's say, not getting to at particular stage, or a person is swapping from content to content on YouTube, or one of the OTVs, what phase, how much time is he spending? So all of those are really a lot of information that with AI and ML we are able to extract data from that information, right? And that's what essentially we are striving for, is to how to use, how we are leveraging AI and ML to take out data from all the information rather, from all the data deluge of data that we will see at the edge, both from an infrastructure perspective, and also the applications and use cases that will consume those infrastructure parts.
That's right. Thank you, Rohit. So that was quite elaborate. And as I move into Kuntal, there's a question that keeps on coming in our minds, that why do we need 5G for edge, right? 5G is an enabler, is it? Can edge also be done over 4G? Is latency the main reason why we keep on saying that we need 5G for edge, or does it help us reduce costs too? So Kuntal, if you can comment on that.
Yeah, thank you. Thank you, Dipayan. This was a great question. And also thanks for all the panelists for sharing their thoughts on why AI and why edge, and all the use cases. Is a great discussion so far. From Mavenir perspective, we have deployed AI commercial deployment in tier 1 operators for around the world for applications like fraud detection. Automatic signaling, plain fraud detection has been in existence. So our AI capability, we are building based on our experience that you're deriving from these deployments. And there's always an equation for cost. So if the cost is not controlled for this deployment, for the edge and applications, this will not take off. But it's so important for 5G, because 5G is all about these use cases that you all mentioned today. And these use cases has to be delivered in a cost-effective way. And in oftentimes, we talk about consumer services, and all the operators are deploying 5G, but consumer services are what? I mean, video, some sort of a video centric deployment like AR, VR, or video analytics based on the feeds of video from different places like facial recognition and object detection. But how do you deploy this with cost that is controlled? So, for example, if you look at it from consumer perspective or the device end user perspective, the cost of the devices or the sensors or actual devices, for example, AR VR headset, if it costs $2,000 to buy for great user experience, because the cost of a device has linked to the user experience. If the user experience is bad, it will not be service that will not be adopted. But how do you reduce the cost of the device for the end user so that it gets mass market adoption? That is one of the objectives of applying AI technology at the edge. From sensors perspective as well. So I mean, if you look at the industrial use case where the factories are not really with the most modern equipment, and how do you really apply advanced control, process control, and sensory network on those devices, on those machinery for predictive maintenance if you don't have simple sensors, simple devices doing this intelligent operation? That's where AI comes. So this edge AI, where you can process this signals and information in a most cost-effective way, is a key enabler for this mass market adoption of 5G in general for all the new use cases that you're talking about. That's from the end device perspective. But from the operator's perspective, when you look at deploying, as you saw in your summary chart, the Airtel and Vodafones of the world are deploying data centers at the edge, and there's a transport cost to it. There's a cost of rental and energy cost, a space cost, and also maintenance cost. So how you reduce those costs will be key to actually make this deployable. For example, if you don't have the right platform for running these AI inference engines at the edge with accelerators built into the hardware, you will have a solution that will not be cost effective. The footprint will go, the energy consumption will go high. So acceleration at the edge in the platform built in is very important, and that's why we're working with the partners like NVIDIA and Intel to build these accelerators right at the edge solution. When you're building this a solution, also it has to be manageable with respect to the footprint, and how do you manage the footprint when the workload goes up? For example, density. So one of the panelists talked about the RAN use cases. How many radios you can manage, and how much workload that is will be that's related to the density of what the solution will do. I mean, how many endpoints, how many sensors, how many cameras, right? So there's an OpEx CapEx equation of the density of this edge solution, which is also what we're focusing on. We need to reduce the footprint and keep the density high at the same time, which is very difficult to do, which is absolutely essential for this to take off. Third thing is transport costs. So, I mean, if you deploy all these data centers at the edge, and if you don't aggregate and process this, I mean, if you look at this video analytics application where what you're trying to do, you're trying to just inspect these video frames and detect something, only that portion of it, right? You don't need the whole video stream to be streamed to the data center and store this video and analyze it, which is the cost. Transport cost and storage cost has to be reduced. So that's why AI is so important, where you're inspecting the video streams right at the edge so that you can make inferences. And there's also, I didn't talk about latency, but that's exactly what it is. So you're trying to define a solution which detects all this in real time at the edge without having to transport all this back to the network or data centers where you can process it. So there's a cost to of transport and storage. And the last one is about support and maintenance, right? So unless these devices are fully tested for not only for the plumbing part of it, which is the RAN and the core elements, how do you package them together, but also the application and also the platform, fully tested edge solution with AI is what we need to focus on as an industry, so that it can be deployed, managed, and supported by the enterprises and operators with least amount of cost. So Mavenir's goal is to make this enable, make this AGI possible, focusing on the cost aspect and also building the whole stack fully tested.
Right. That's great, Kuntal. So Vijay, as we go to you now, especially Tangentia has been a global boutique digital transformation company, right? And there have been very very interesting applications that we have seen that you have been working on. What have been some of those applications that have seen primary pull as regards to the use cases that we were talking about, whether it is RPA or AI, and essentially the cloud SaaS solutions, if you can talk about that.
Absolutely. Thank you, Dipayan. And it's wonderful with having all this great panelists here. Manish, I'm going to steal your idea of the central nervous system and the brain. I think it's fantastic, especially with the inference and learning. Also, if you can add in muscle memory, it is actually when the end learns and then it goes back to the brain, and the brain can send back. So that's almost like it's like a Tesla car, when in the end of the day goes and goes back and it sends back new learning. So the inference is richer. I mean, that's a fantastic analogy right there. So for us as application builders, I think we are able to decide on a spectrum. All of these are trade-offs, right? I mean, where do you want, how much is on the cloud, how much on the AI, right? And to Kuntal's point, cost drives some of that, right? Privacy drives some of that. So when privacy comes in, cost doesn't matter, right? So these are some of the things where recently we were working on especially in countries like Canada, where we is our headquarters. We were working on a COVID application for and COVID has been a good time for us in the business to explore some of these edge applications. And the reason why the cost was very high, but it did not matter. We had no option but to go to an edge thing, because the privacy, for privacy reasons, the person's data had to be on their device. There was no way that could be sent to the cloud. So whatever we came up with, that couldn't happen. So there are different criteria that we have to follow. And then I think this makes it, and this makes it also ever changing, because the costs could change. With 5G, the cost could change again, right? I mean, so today's decisions that you might make on how much is going to be on the edge and how much is going to be on the cloud, the moment is widespread, 5G, propagation around the world, those decisions will again change. So you'll have to move the needle on that differently. So I think there is no real answer. I think a lot of this is evolving as we go along. So the example that I gave about the COVID application that we built, and this was specifically for school boards, where parents wanted to find out if their kids had there's something called as a COVID passport. Now, how do we take a COVID passport in a way in which it's on a device, as well as there's some bit of central processing happening as well. So this gave us a very very good idea that we had to do a lot on the device itself for privacy reasons. But once maybe 5G came in, and we do have some bit of 5G, not all across. It opens up more capabilities, and more processing can happen on the cloud as well. So I think as application developers, a lot of what all of you are doing is fantastic stuff. We need all the highways, we need all the infrastructure, all of that in place. And once that is done, it provides the people like us the capabilities. We can then pick and choose. It gives us more architectural options. And I think that is I think from my takeaway on this is it is getting richer. It's not just one template that we have to follow. There's multiple templates, and then if you're developing something for the cloud, keep an eye on how this is going to change. What is going to be the cost of 5G? How is 5G really going to make that difference? And that's where I think where the big differentiator is going to be. Some of our options, some of our things that we're costs may not be the same going forward.
Right. So that's quite interesting, Vijay, and especially your work around COVID. Let me bring in Ameeta out here, and thanks to you for having been waiting so patiently. So while we talk about implementing these applications, and your domain have been around creating an optimized architecture, right? We have been talking about workloads. We have been talking about the cost of deploying AI on the edge. How do you see the architecture, especially by bringing in a DevOps environment, by bringing in a hybrid environment, which is secure at the same time, integrated in a brownfield scenario, if you will,
Absolutely.
which is required in this kind of a deployment?
Absolutely, Dipayan. So one thing I think has been fairly clear by now, that edge computing is very disparate, right? So what is really required is consistency. So an edge deployment, as we've been hearing, could theoretically be anything, right? Small form servers on cell towers, it could be sensors monitoring some global energy network, or it could just be a next generation factory automation system that has to anticipate some maintenance need. So it's fundamentally impossible to manage each of these deployments if they don't share some kind of a common platform, so that there is some kind of a secure control plane, and you have automation, management, and orchestration. And this is the consistency that Red Hat tries to offer through the hybrid cloud. So that from the edge devices to the network to the centralized data center, a hybrid cloud deployment will actually provide sanity to what would otherwise have been sheer madness across a technology ecosystem that is very, very varied, right? And underlying this is typically an operating system like Linux, a way of developing in a modular manner like Kubernetes, and using some kind of automation like Ansible. So when you look at edge, it is really like the newest IT footprint, right? It becomes an extension of the data center, just like you had bare metal, virtual environments, private cloud, public cloud, right? In many ways. And the small physical footprints, remote locations, and limited connectivity of the edge devices really poses a challenge. And that is where an operating system like Red Hat Enterprise Linux, for example, it can easily span from the core data centers to the space-constrained remote servers. And it has been built to provide the levels of supportability, stability, and security features required by those edge deployments. Like, for example, how can you rapidly create operating system images for the edge? How can you do device updates, where you only apply updates at the next device reboot or power cycle, so that you can limit the downtime and any manual intervention that's required. Then things like over-the-air updates, where you're transferring very little data, only enough to push the necessary code, and then what kind of rollbacks you can do. So one part of it is providing some kind of a single production grade platform that can span the entirety of an enterprise. The second part of it is that the benefits of edge computing can really be only realized through applications, right? And as we move increasing to the edge, we will have to look at treating edge computing, while it is a separate computing paradigm. We still have to look at how developers can build edge applications that are still leveraging modern application development principles, but those principles will never go out of style. So it could be in terms of consistent tooling, regardless of the location where the application is deployed, things like open APIs, and then using highly modular and yet scalable technologies like containers, Kubernetes, etc. And finally, when you talked about DevOps, the unique challenge that we have is to create an automated environment. And in order to do that, we need to have a unified automation language that enables you to tie the edge back to your data center as required, right? And for DevOps to work, it has to be a shared language between domain experts as well as application developers, so that you're bringing forth some kind of cooperation on exactly the same mission, so that they can all combine their expertise, work together, and build some streamlined automation that could span across storage, networking, infrastructure, etc. So with Ansible automation platform, it's built around such a language today. So you can connect your assets at the edge with your core platforms. And then to actually excel at the edge, we also need to have some kind of solutions to automatically transform events into actions, right? So that is where event-driven automation comes in, which enables applications to be decoupled, reactivated, scaling only when an event happens. And in order to enable and democratize this, really, serverless architectures are really coming into place that leverage things like Knative from the open source community and cloud events. And then finally, if you're able to combine all these, and this is where we help customers with the Ansible automation, where does it live in that vision? Wherever you need to integrate automation into anything outside Red Hat OpenShift container platform, which is the Kubernetes orchestration layer that can span across your hybrid cloud environment. And then finally, you deploy more consistent, more stable Kubernetes clusters. And when you look at advanced cluster management for Kubernetes, that will help you put all those resources where they're really required, especially where connectivity to the internet, may or may not be reliable, right? And finally, another area that we are working on is an AI ML industrial, at least to start with, industrial manufacturing blueprint that's now currently available in the GitOps repository, which anyone can use, study, and even contribute to it. So for a complete edge ecosystem, there's not one single vendor. It has to be an ecosystem. And that's the reason why we feel it will be driven by an open hybrid cloud. And that is the vision towards which we at Red Hat are working.
Yeah, perfect. And, it has been a wonderful discussion today. And this was not artificial intelligence, this was human intelligence, isn't it? So, what, it's the writing is on the wall that AI Edge is expected to revolutionize the market. It will create wider capabilities. It will enable new use cases and play a major part in the world's move towards an era of intelligent creativity. But with specialized infra, a software which can be provided as a service, which is actually built as a part of an ecosystem, and an environment which is cost effective. It can enable real-time predictions, and obviously 5G would essentially give a major boost to it. So if I have to conclude, and I just run across the panel, what would be those 2 words of advice, and literally 2 words, I mean, that you would give for anybody wanting to go into putting in AI on the edge? Manish? Manish, you're on mute.
Oh, sorry. I was trying to say capture the possibilities.
Perfect. Okay.
Costs will make sense later.
Right. Sachin?
I thought I could just lip read Manish and repeat his answers, but mine would be secure and adaptive.
Perfect. Rohit?
Bridge to possible.
Yeah, that was short and crisp. Kuntal?
Simple and cost effective.
That's nice. Vijay?
I would say agile and scalable.
Perfect. And to you, Ameeta?
I would say it's open and on the hybrid cloud.
Wow. That pretty much sums up what we discussed today. So it has been wonderful, guys, to have you all in the panel today, and thank you so much for joining. We conclude the session here.
Thank you.
Thank you.
Thank
Thank
you.
you. Thank you.
Yeah.
Thank you.
Thank you so much.
Bye.